Welcome to our channel. In this lesson, I want us to discuss Form 3 Chemistry topic sulfur and its compound. And in this lesson, we will discuss extraction of sulfur by Frasch process, physical properties of sulfur, chemical properties of sulfur, and finally uses of sulfur.
The Frasch process. The sulfur beds lie beneath layers of clay, sand, and limestone, which makes open mining impossible due to the risk of collapse. The Frasch process is based on the fact that sulfur has a comparatively low melting point. The Frasch pump, consisting of 3 concentric pipes, is sunk deep into the sulfur bed. Superheated water at about 170 degrees Celsius under pressure is pumped into the outermost pipe. The water enters the sulfur bed and melts the sulfur present. Compressed air under a pressure of 20 to 25 atmospheres is pumped through the innermost pipe. This forces the mixture of the water and molten sulfur to gush out through the middle pipe. This mixture of water and molten sulfur is collected, and on cooling, about 99% pure sulfur gets separated. Allotropes of sulfur.
Allotropes are different forms of an element but in the same physical state.
Solid sulfur exists in 2 different crystalline forms. These are called rhombic sulfur and monoclinic sulfur. Both forms are made up of pure sulfur. They differ in the shape and heat stability of their crystals.
Rhombic sulfur can be prepared by recrystallization from a solution of sulfur in carbon disulfide. The solid is not very soluble in the solvent, and the excess is filtered out. The solution is left to stand for some time to allow carbon disulfide to evaporate completely. Slow evaporation of carbon disulfide produces crystals of rhombic sulfur, as is on the screen. Monoclinic sulfur is only stable above 95.3 degrees Celsius. Needle-shaped crystals of the element can be prepared from molten raw sulfur. The sulfur is melted carefully and then allowed to cool. When cool, holes are made in the crush which forms on top of the liquid sulfur. Once the solid crystals form, the molten liquid inside is poured out through these holes. When the cool solid is broken open, monoclinic crystals can clearly be seen.
Thus, below 96 degrees Celsius, crystalline sulfur exists in the rhombic form, and above 96 degrees Celsius, it exists in the monoclinic form. The temperature 96 is in this case called the transition temperature. Physical properties of sulfur. Sulfur is a yellow odorless solid which is insoluble in water but soluble in organic solvents like carbon disulfide and methylbenzene. At ordinary temperature, sulfur exists as a solid covalent substance. Each sulfur molecule comprises of a crown-shaped ring consisting of 8 sulfur atoms. The atoms are linked by strong covalent bonds forming an S8 molecule. Individual molecules are linked to one another by weak intermolecular forces such as van der Waals forces. The molecules are packed regularly, forming crystals, and are present in both rhombic and monoclinic crystals. When sulfur is heated, it melts at 113 degrees Celsius into a clear pale yellow liquid that flows easily. At this point, the intermolecular forces are broken, separating the individual molecules, resulting in liquid sulfur. On further heating, the liquid darkens, becoming reddish brown, very viscous and hardly flows. This is because as heating continues, some of the covalent bonds break, leading to the formation of long chains of atoms. The chains get entangled, causing the liquid to become viscous and dark. In fact, at some point the test tube can be inverted without the sulfur pouring out. As heating continues, the liquid becomes black and flows easily once again. This is because more covalent bonds break, resulting into smaller molecules which are less entangled. This makes the liquid less viscous. At a temperature of 444 degrees Celsius, the liquid will boil, forming a brown vapor because the molecules become smaller and smaller. But anyway, when boiling sulfur is suddenly cooled by pouring it into cold water, see what happens. The product is elastic and is called plastic sulfur. If this plastic sulfur was left for several days at room temperature, it will harden into rhombic sulfur. Good. Now we look at the chemical properties of sulfur. Reaction with air. Sulfur melts and catches fire, burning with a blue flame. It burns in pure oxygen with a brilliant blue flame. In either case, sulfur combines with oxygen to form sulfur dioxide, which has a choking smell. Traces of sulfur 6 oxide are also formed. The sulfur dioxide dissolves in water to form sulfurous acid. Reaction with iron. When a mixture of iron and sulfur is heated, it starts to glow. The glow continues and increases in intensity even after the heating is stopped. This shows that the reaction is exothermic. A black solid of iron 2 sulfide is formed. Other metals like zinc and copper also react with sulfur when heated, forming metal sulfides. Sulfur does not react with dilute acids. However, concentrated sulfuric acid oxidizes sulfur to sulfur 4 oxide. Again, concentrated nitric acid oxidizes sulfur to sulfuric acid and is itself reduced to nitrogen 4 oxide. Sulfur is used in the manufacture of sulfuric acid, which has a large variety of industrial uses. Vulcanization of rubber, that is hardening of rubber to tough substance that can be used to make tires. Manufacture of gunpowder, explosive, matches and fireworks. Manufacture of sulfur drugs, insecticides and fungicides. Manufacture of calcium hydrogen sulfide for bleaching wood pulp. Manufacture of carbon disulfide. Manufacture of sodium thiosulfate, which is used in photography, and manufacture of artificial hair dyes.